Okay, so modeling of forced oscillations of mass spring system. So this is the topic which is after the modeling of free oscillations. So in the case of the forced oscillations, there is an external force on the mass. Okay, so for example, if this is the mass, and then one of the force will be the weight of the mass mg, and the other force will be the restoring force from the spring. Okay, k times its distance y, and another restoring force will be the damping force, internal damping of the spring, which is represented by cy prime. And then now there is an external force. So suppose the mass is moving downward, so we can represent that downward force. Okay, maybe the driving, we call it as a driving force. Okay, forced oscillations. So the resultant of these forces will be then represented by uh, the resultant of this. We can represent the resultant of these forces. Okay, uh, so how we can represent it? Yeah, so for that representation, we will take some little bit vertical coordinates. So for example, if this is the initial position of the spring, okay, and as a result of mass, okay, as a result of this weight, the spring moved by a distance of say s naught, and then the spring was also pushed downward to some other position like y. Okay, it may be by the external force. Okay, so so then total spring force will be given by the k times y plus s naught. Okay, and for the initial condition, that mg will be equal to ks naught. Okay, as we have done in the case of the free oscillations case. Okay, so let me write down all the forces. So this force is the cy. I will write negative because positive direction was taken as downward direction. Okay, so this is the damping force, and then minus k times y plus s naught. So this is the total stretch in the spring. Okay, so out of this total stretch in the spring, ks naught is balanced by this uh, weight of the mass, so plus mg. That means weight of the mass and the ks will be equal to each other, and they will cancel out. We have already seen it in the case of the modeling of the free oscillations. Okay, so later on we will cancel out, and then there will be the driving force. So the resultant force, as we have already shown before, the resultant force will be equal to the mass times the acceleration, which is represented by y double prime. So if we just simplify it, cy prime minus ky minus k s naught plus mg plus driving force. So this will be equal to my prime. So out of this will equal to 0. So what is left is minus cy prime minus ky plus driving force is equal to my prime. Or if we rearrange the terms, so then we can write it like this: my prime, my double prime plus cy prime plus ky is equal to the driving force. Okay, so this is the second order differential equation, non-homogeneous equation, and this is for the forced vibrations. Okay, this is the equation for forced vibrations. So in this case, this driving force is, we can we take the driving force in terms of the cosine function, or we can even take in terms of the sine function as well. So fd is the driving force, so we take normally in terms of the cosine function, whereas the argument of the cosine we take as omega t. We will I will this why we take as omega t, this will be cleared very soon. And so first of all, why we take as a cosine function? Because the motion of this mass attached to the spring is oscillatory motion. Oscillatory motion means going downward, going up, and then going down, up, down, up, down. So for that, for representing that up down motion, we should have some function over here. So for example, the driving force also change in direction periodically. So the cosine function or even sine function can provide such a capability. So therefore, we take a value of force F naught, okay, which is a constant, and then multiply it with the variable cosine function, so that the direction of force can vary. So for example, for some values of omega t, the value of cosine will be plus, okay, downward, and some values of omega t, the values of cosine will be negative, the force direction will be upward. So therefore, this force will match with the motion of the spring. So that's why we take the cosine function. So therefore, our equation becomes like this: my prime, m double y prime, my double prime plus cy prime plus ky is equal to f naught k, or cosine of omega t. So for this, since this is an non-homogeneous second order differential equation, and it's a non-homogeneous function, f naught cosine of omega t is in terms of a cosine function. So its a particular solution will be this: yp is equal to a cosine omega t plus b sine omega t. We are representing it in terms of the omega t is because if you remember that in the case of the free oscillations, we represented a term k over m as omega naught, okay, which was related with the natural frequency of oscillation, okay. So one will be the natural frequency of the oscillation, and then this omega will represent the frequency of the force, okay. This omega will represent the frequency of the force. So that's why we took, instead of just alpha t, beta t, we take it as a omega t, so that both symbols omega naught and omega will be considered. So this will be the particular solution. So for this particular solution, we will need to find A and B. And of course, in addition, there will be the homogeneous part of the solution. So the general solution will be the sum of the homogeneous parts and sum of the particular part of the solution. So if we need to find the values of A and B, so for this, we can take a derivative of this equation. So y prime p will be equal to minus a omega sine omega t plus b omega cosine omega t, and the y double prime will be equal to then minus omega square a omega square cosine omega t, and then this will be also, because it will cosine, so it will be minus b omega square or omega square b sine omega t, okay. So now from the method of the undetermined coefficients, so we can input this a value, these values into this equation, and then we can equate the coefficients of cosine and sine. So therefore this will become, if we put y double prime, then it will become minus omega square ma cosine omega t. Then it will become minus omega square mb sine sine omega t. Okay, so this m will be multiplied by y double prime, and then for y prime it will be multiplied by c, so it will be minus omega ac sine omega t minus omega bc cosine omega t. Okay, and then for yp it will be multiplied by k, so it will be, so it, yeah, this will be plus, yes, so minus minus plus. Okay, and then this will be plus a ka cosine omega t plus kb sine omega t. Okay, and that will be equal to a cosine, that will be equal to f naught cosine omega t. Okay, f naught cosine omega t. Okay, so now collecting the terms of the cosine and sine, only then these two equations will be equal. So for collecting the terms of the cosine, we get like this. So for the cosine term, so first term will be minus omega square ma, okay, cosine omega t. Okay, and then the second term will be the plus omega bc, okay, omega bc cosine omega t, and then plus ka, plus ka. So all of these are the cosine terms, minus m omega square a minus omega square ma plus ka and plus omega bc. So this will be equal to f naught. Okay, because on the right hand side there is cosine omega t, so we have collected the terms of cosine omega t. And then for so here we can just also collect the terms of a as well, so it will be minus m omega square, okay, and then a is common, and then plus k, a is common, so it will be a, and then it will be omega c, and then b, because we want to find a and b, so we need to have the equation in terms of a and b. Okay, and then after that we can collect the terms of sine. Sine terms are minus omega square m b, and minus this one is the AC, minus omega AC, and then this term is plus kb. This is the sine omega t, plus kb sine omega t, and this will be equal to 0 because on the right hand side there is no sine omega t term. So similarly then we can represent it into the a and b format, so it will be minus omega c and then a times a plus this will be then b if we take common, so it will be k minus omega square m, or minus, it will be minus m omega square plus k times b is equal to 0. So now we have these two equations, okay, one of this